Lights turned off here in a moment. But today is all about determinants. And once again, we're going to focus on a square matrix. Okay, last week we talked about inverses. Was that, yeah, that was last week. Last week we talked about inverses, and we can only find an inverse if we have a square matrix. Same thing with a determinant. We can only find a determinant if we have a square matrix. Which, by the way, did any of you non-juniors do the decoding stuff? Mm-hmm. Yeah, so pretty cool. Did you write messages to each other? Did you write messages to each other?
Looking at the end, or yeah, we did that.
Okay. Every square matrix can be associated with a real number called its determinant. Okay? And would you believe it if I told you that you already know how to take a 2 by 2 determinant? First of all, I do want to tell you about the notation. Okay. If we're finding a determinant, then instead of the brackets, we're going to have what looks like kind of absolute value bars. So if we have the absolute value bars where we usually see the matrix bars, then that means determinant. Okay, I'm going to go ahead and pause for 1 second here. This is not lining up, but it's bothering me. Okay, so you actually know how to find a 2 by 2 determinant. What's that from? Okay, this AB minus BC, that's the number that you use when you find a 2 by 2 inverse, 1 over that. You actually know already how to find it. Okay, so I'm going to put a matrix up here on the board, and I want you to find it. So write down the matrix and then find the determinant. Okay, what I want you to notice is that this looks like a matrix, but do you notice how they're bars instead of the boxes? Okay, I don't even need to say find the determinant. When you see those vertical bars, it automatically tells you you are finding the determinant. Liam, what do you get? 7, you say that very unsure. What? Can you tell me about your work? What did you do?
Well, I'm looking for 2 by 2.
Uh-huh. Yep.
Then, subtracting -3 or adding 3, 4.
Do you agree with me? Yep. Chris. Oh, sorry. Chris minus cross. 4 minus -3. Our determinant is 7. Okay. So we got another one. Not that you need to, but we need to talk about a special case. We have the 2 by 2 matrix of 2, 1, 4, 2. Eli, what would the determinant be?
0.
Okay, now let's think back to what this would mean about an inverse. This number appears where when we're finding our inverse? In the denominator, right? When we found an inverse, we said 1 over AB minus BC, switch, and negate. So if this number was 0, what did we say? Okay, there wasn't going to be an inverse, right? So in this case, since the determinant is 0, we also know that the inverse will not exist. And that's going to be true about any size of matrix. If you find the determinant of a square matrix and it ends up being 0, no matter what size it is not going to have an inverse. All right, one more 2 by 2 example that looks a little bit different, and then we'll look at how to find a 3 by 3. Okay, so we need to solve for x. What you really need to notice, because it says nothing about a determinant, but you need to notice that the bars on the outside of the matrix are vertical as opposed to the boxes, and so that means determinant. Well, how do we find a determinant? We take Chris minus Cross. And that should equal, in this case, 0 because it's telling us that our determinant equals 0. So now they want to know what x is. What are we going to have to do? Okay. We're going to have to, we have a quadratic essentially, right? But we can't have a quadratic that equals 14. We're going to have to multiply this out and then refactor to set equal to 0. So when we take x plus 4 times x minus 5, we get x squared minus x minus 20. Okay. We're subtracting a negative 14, so that's like adding 14. So what we end up with is x squared minus x minus 6 equals 0. All right, how do we factor that? Caleb? So to answer the question, x is 3 or x is negative 2. All right, how do you feel so far? Kind of nice, right? Okay, I am going to show you the steps for any matrix that is larger than a 2 by 2. I would like you to write them down, and then we will talk through them and what they mean with specifically a 3 by 3. By hand, I'm really concerned about a 2 by 2 and a 3 by 3 matrix. Okay? So I'm going to put the steps up here. I want you to take a moment, and I want you to write these down. could, if you wanted to check to make sure the determinant was 0, to make sure you did your work right. But the problem only asks us to solve for x, and so once you get x, then you can use it. Okay. So this, there's actually two different ways to find determinants of specifically a 3x3. If you look in your book, you might see this method called like expanding by minors. I don't want you to worry about that method. I want you to worry about this method up here because I think it streamlines very nicely with how we find our 2x2. Okay, we still basically have a criss minus cross pattern. Just the more rows and columns, the bigger the matrix, the more crisscrosses we're going to have. Okay. So go ahead and write down this generic matrix. A, B, C, D, E, F, G, H, I. Okay, so it says copy everything but the right column. Okay, so the right column is CFI. Do you agree? Okay, so we're going to recopy everything but that column. So our first column is A, B, G, and our second column is B, E, H. Okay. So everything except the right column. Now we're going to take products of our down diagonals and then our up diagonals. So what I mean by down diagonals are these right here. We're going to start in the top left corner, and we're going to create as many diagonals of 3 terms as we can, since it's a 3x3. If it were a 4x4, we would have 4 numbers in our diagonal. Okay. So our down diagonals. Okay, this is what we're going to do. We're going to take A times E times I, and we're going to add it to B times F times G. And we're going to add it to C times D times H. Those are your down diagonals. Then we're going to subtract the sum of our up diagonals. Please notice how I'm putting these in parentheses. All of our up diagonals I'm going to group together in parentheses, and all of our down diagonals I have grouped together already in parentheses. Okay, so we did our down diagonal. Now go to the bottom left corner. So we started at the top left. Now we're going to start at the bottom left, and we're going to go up with our diagonal. So G times E times C. We're going to add that to H times F times A. And and we're going to add that to I times D times B. Since this was a 3 by 3 matrix, we're looking for any diagonals that have 3 terms, or 3 entries, I guess I should say. Once we're out of diagonals with 3 terms, then we go to the up diagonal. Okay? So let's go ahead and practice this in real matrix. Okay, so what we're going to do, we're going to copy everything except the right column. So I'm going to make this a little bigger for myself. Okay, we're going to copy everything but the right column. So our first column is 3, 3, negative 1. And then our next column is 4, 5, 4. Okay, now, I do think you can do some calculations in your head. However, you cannot do all calculations in your head. I need to see some work. Okay, so we're going to start with the down diagonal. Start at the top left corner. What is 3 times 5 times 1? Plus 4 times 0 times, it doesn't matter. Plus negative 2 times 3 times 4. Those are our down diagonals. I'm grouping those together. And then we're going to subtract our up diagonals. So negative 1 times 5 times negative 2. Plus 4 times 0 times, it doesn't matter. Plus 1 times 3 times 4. Okay. So then, piece by piece, what is 15 minus 24? Negative 9. Minus 10 plus 12 is 22. So our determinant is negative 31. Thank you. I don't want to have to do all the work up here. Awesome. I'm going to erase all my marks so we can see it. Get out your calculator. Let's go ahead and check our work here. All right, I would like you to go ahead and put this 3 by 3 matrix in your A matrix. Give me a thumbs up if you need more time to enter those numbers in. Okay, so go to second click, go back to your calculation screen. And if you go into your matrix menu, in that middle math menu, DET stands for determinant. So you'll click that DET and bring up your matrix A. Okay. there will be a non-calculator and a calculator portion of Tuesday's test. You're probably going to have to find a determinant using your calculator, and it's probably not going to be of a small matrix to where you would want to do it by hand. Okay, so you will need to know how to do this in your calculator. All right, so I am going to give you one that I would like you to do by hand. Okay, so I am going to write it up on the board if you give me a moment here. Please find me the determinant of -3, 2, 1, 4, 5, 6, 2, -3, 1. By hand, please find me this determinant. Feel free to check with your neighbor when you both get answers. Tomorrow, I'm going to put you back in. Courtney, what do you get? -75. Do you agree? Anybody not get -75?
I did get -75.
Eli's being difficult. Okay.
Right.
All right, so Caleb asked me a good question. What is the point of determinants? What are we going to do with them? I don't get why we're finding them. First of all, what we know right now is that if we can find a determinant, then we know that that matrix will have an inverse. If the determinant is 0, we know the inverse will not exist. Right now, we at least know that. Tomorrow, we're going to go into how we can use determinants. We're going to use determinants tomorrow to solve a system of equations. We're going to use determinants to find area of a triangle. We're going to use determinants to write the equation of a line. And we're going to use determinants to test your collinear points. Those 4 things we're going to do tomorrow for you. Okay? Now, it is 8:31, and we have until 8:50. What? right? Isn't this awesome? Now, today is kind of wacky. We have state volleyball. We have uh, Titanium has like hours and hours of rehearsal, and who knows what else you guys have going on in your lives. What if you could get your assignment done before you left? What if? I challenge you. Please look at your gold sheet because I think there are instructions about calculator and non-calculator. No, there's not. Pay attention to the wording in your book, calculator versus non-calculator. You need to do them both. You need to be able to do them both by hand and with a calculator, but just pay attention to the instructions of the book. Let's get to it.
My calculator showed me the work.
What did you say?